So good morning everyone. In this video we will see how chi-square test is used for goodness of fit test. So problem definition is records pertaining to the monthly number of the jobs related injuries at an underground coal mine were being studied by the federal agency. The value of past 100 months are as follows. So along with the problem statements, they have given the injuries per month and frequencies of the occurrence. So this data they have given. The total size of this data is 100, that is n is equal to 100. So apply chi-square test to these data to test the hypothesis that the distribution is Poisson with alpha is equal to 0.05. See, they have given this data and they are asking us to find out whether this data is distributed or according to the Poisson distribution or not by considering alpha is equal to 0.05, that is level of significance. See, in the above problem statement, the estimator S is not given. So we have to first identify the estimator. Then how to identify estimator? So according to the problem statement, the distribution is Poisson. So the parameter alpha and the estimator alpha cap is given by what here? Alpha cap equal to mean here, right? So this is from the table 9.3 and page number 8 to 82. So alpha cap is a parameter of the estimator and x bar is what here? Mean of a data here, right? So the mean value they haven't given along with the problem statement, and alpha cap value they have not given along with the problem statement. So we have to estimate the alpha cap value. So alpha cap value is estimated by using the mean value here, right? That is finding x bar. So the mean of a sample is computed by using following equation, because if you look at the data is distributed in the form of what here? Frequency. The data is grouped into in the form of what here? Frequency. So the formula for finding the mean of a data when the data is grouped into frequency distribution, that is x bar is equal to summation j is equal to 1 to k fj into xj here. So the xj is nothing but what here? The interval, and fj is nothing but the number of the frequency within that particular interval, right? So the frequency in this interval is what here? 35, and in one the number of the frequency is what here? 40. So that we have to multiply fj into xj, and at last we have to add these values, and this is divided by what here? N is nothing but the total size of the data. So we have to add all these frequencies, we will get 100. So we will get a mean as what here? 1.11. So according to the parameter estimation, so suggested parameter is, so that is for the Poisson distribution, the alpha cap is calculated by this formula, that is alpha cap equal to x bar, nothing but what here? Mean, right? So alpha cap equal to 1.11. So now we will construct a we will apply chi-square test for checking a goodness of fit. So first we will find what here? The theoretical hypothesized probabilities for each class interval using PMF of Poisson distribution. So the PMF of Poisson distribution is given by this equation. So we will calculate the probabilities of each class interval, that is P of 0 is equal to e raised to minus 1.11. The minus 1.11 is nothing but what here? Alpha cap value which is computed, right? So the first value is 0.329 and P of 1 is 0.365, P of 2 is 0.197, and so on. All the values, interval probability hypothesized value for all the intervals is calculated. And once after calculating all the hypothesized probability values, next we have to find what here expected value of each interval. So we will construct a table so that this table will be having all the values, right? So xi, so list out all the intervals here, and oi is nothing but observed frequencies, which is given along with the problem statement. So we will list out all the observed frequencies. Next, ei is nothing but what here n into pi, 100 into 0.329, nothing but what here first value, and the next value is computed as 100 into 0.365, right? So on expected value will be computed. So next step is you have to check each and every expected value which is less than 5. If the expected value is less than 5, then that expected value has to be combined with the adjacent expected value. So here the first expected value is 32.95, right? So the 32.95 is greater than 5, so no need to combine. Next value is what here 36.5, this is also greater than 5. So third value is also greater than 5, fourth value is also greater than 5. The fifth value is this value is what here less than 5, so this is combined with the next value, and all these three expected values are combined, and the combined value is 3.57. The corresponding OI has to be combined. So the corresponding OI value of 2 is 4, 0.4 is what here 1, 0.08 is what here 1. So all these values are combined, then this is what here 6. So next we will calculate OI minus EI bracket square, that is 4.20. So this is 4.20, this is 12.25, and so on. So once after doing this, OI minus EI bracket square divided by EI will be calculated. So the final value we get for chi-square is what here, that is chi-square 0 is what here 8.54, and the critical value is obtained from the table, that is x chi-square alpha comma k minus s minus 1. So the k is nothing but what here the intervals after combining. So how many intervals are there after combining? 1 2 3 4 5. So that is 5 here. Minus 1 means what here the parameter. So how many parameters are related to the Poisson distribution? Only one parameter, that is alpha square. So next is what here minus 1. So therefore chi square 0.05, so this is what here 3. So this value is obtained from the table, from the book, right? So you can see here, so the chi square value, that is, so when the value is the n value is what here 3, then it is what here 0.05, 7.81. So this is what here the value obtained from the table, and this value is compared with the computed value. The computed value is, that is 8.54, this is greater than 7.81. So therefore the null hypothesis is rejected. Thank you.